In this lesson, we are going to look at the concept of efficiency. Now, when you throw a ball, it will bounce for a while, but it will eventually stop. Likewise, when you raise the bob of the pendulum, after a few swings, it will also come to a stop. Similarly, when you exert a force to pull a vibrating spring, after a number of vibrations, it too will come to a stop. Why did all these systems stop? Now, notice that for each of these systems, there is an initial energy that is transferred to the system. When we raise the ball to a specific level, the ball gains in gravitational potential energy. That energy gets converted to kinetic energy as it drops to the ground. In that process, some of the gravitational potential energy is converted to heat and sound energy that are lost to the surroundings. When the ball reaches the ground, all the gravitational potential energies have been converted to kinetic energy, heat, and sound energy. Therefore, the amount of kinetic energy that the ball has at this ground level is less than the original gravitational potential energy that it first gained when we raise it to this level. Hence, when the kinetic energy causes the ball to bounce up, it can only raise the ball to a maximum height that is much lower than the original height that we first raised it. So you see, only the kinetic and potential energy that are in the system produces the useful work of enabling the ball to bounce. The energy that is converted to heat and sound energy and therefore lost to the surroundings become wasted energy because they are out of the system and cannot be converted to kinetic or potential energy to enable the ball to bounce. Hence, if we measure the amount of energy we first exerted, or we call the energy input, versus the work done or useful energy output, we can calculate the efficiency of a system. For example, on this slide, we have a man trying to pull a load up using a pulley system. The energy supplied is E, and the total energy lost due to energy conversion to sound, heat, and friction is X. What is the efficiency of this pulley system? Now, let's apply the formula. First, we need to calculate the useful energy output or the work done. Since we are given energy supplied to be E and energy wasted is X, then the useful energy output or the work done is E minus X. We divide this over the initial energy input E, and with that, we get the answer to be D. So you see, the concept of efficiency is very simple. However, examination questions can become tricky when we have to calculate work done with specific parameters such as the height or distance moved by the object, or the velocity and hence the kinetic energies and gravitational potential energies of the object. We will learn more about calculating work done in the next module. Questions on efficiency can also involve electrical power. For example, the product specification of an electric iron may state that it has a power consumption of 2.7 kilowatts. You will learn more about power in Module 3. Power is defined as the rate of energy transfer. So what the power consumption of 2.7 kilowatt means is that the amount of energy transferred to this electrical appliance is 2.7 kilojoules per second. This 2.7 kilojoules is therefore the energy input per second. If you are told that the efficiency of an appliance is 80%, it means there are 20% energy wasted. To calculate the amount of energy wasted per second, we take the 20% multiplied by 2.7 times 10 to the power of 3 joules, and that gives us 540 joules. Take note that this 540 joules is the wasted energy per second. If the appliance is in operation for say 5 minutes, then the amount of wasted energy will be 540 joules times the duration of 5 minutes times 60, because we need to convert it to seconds using SI unit. When you are doing your calculation, remember to always work using SI units. This is why we multiply by 10 to the power of 3 to convert kilojoules to joules. Now let's do a quick summary. In this lesson, we learned that efficiency is computed using useful energy output, which is work done, divided by the energy input times 100%. Energy that is lost to the surrounding is called wasted energy. An appliance rated at X kilowatts power consumption means there is an input energy transfer of X kilojoules per second to the appliance. This concludes our first module on energy. In the next 2 modules of this course, you will learn about calculating work done, power, and how to solve examination questions. Do remember to subscribe to my channel so that you will be alerted when I post a new lesson. If you find this lesson has helped you, visit my website for more video lessons. On my website, there are practice questions that have been carefully curated to help you reinforce your understanding.